Hello everyone, this presentation is about NLTK functions for natural language processing. Here NLTK means Natural Language Toolkit. This presentation is done by Raghuram Raju Nadimpalli and Narendra Bandaru. Firstly, I am going to introduce about this topic. Natural language processing is a subfield of artificial intelligence that deals with interaction between computers and humans in natural language. NLP involves a variety of techniques and algorithms to analyze, understand and generate human language. One of the most widely used libraries for NLP is NLTK, that is Natural Language Toolkit. This is a platform for building Python programs to work with human language data. NLTK provides various functions and tools to process natural language text data, and this is also widely used in academics and industry. The reason why I choose this tool is it has wide range of functionalities and it is an open source. It is open source software, which means that is free to use, and it has a large user community, and it is also very easy to learn, and it is extensible and customizable, and this is also education focused. And the history of this NLTK toolkit is it was developed at the University of Pennsylvania in the late 1990s by Stephen Bird, Edward Looper and Ivan Klein. They developed NLTK to provide researchers and developers with a comprehensive set of tools for working with human language data. The primary goal behind NLTK was to create an open source platform that would make it easier for researchers to experiment with natural language processing techniques and develop new ones. NLTK aimed to provide a common set of tools and resources that could be used by researchers and developers worldwide. NLTK provides a wide range of methods and tools for natural language processing. Some of the most commonly used ones are tokenization, stemming and lemmatization, parts of speech tagging, named entity recognition, and sentiment analysis. Firstly, we are going to discuss about tokenization. This method involves breaking down a text into individual words or phrases known as tokens. NLTK provides various tokenizers such as word, sentence, and regex tokenizer. I'm going to explain an example for this. Consider the quick brown fox jumped over the lazy dog. So the tokenized output will be the is a token, quick is a token, brown is a separate token, fox token, jump token, over token, the token, lazy token, and dog. It's a token. And then stemming and lemmatization. These are the methods used to words reduced to the root form. Stemming involves removing the suffix from the words, while lemmatizing involves converting words to their base form. NLTK provides stemmers and lemmatizers for different languages. Consider an example: the cats were playing with the mice. So the stemmed output would be the cats is reduced to cat. As we know, stemming involves removing suffix from the word, and where playing is reduced to play with the mice, and the lemmatized output would be the cat, we see where is being reduced to its base form b, and then playing with the mice is reduced to its base form mouse. Parts of speech. This method involves identifying the parts of speech of each word in a sentence. NLTK provides various POS taggers such as default tagger, regular expression tagger, and maximum entropy tagger. Let me explain an example. She sells seashells by the seashore. Here we see she is a personal pronoun, PRP tagger, and sells is a verb, third person singular present, VBZ tagger, and seashells is a noun in the plural form, that is called as NNS, and by is an preposition which is called as in, and the is a determinator, so it is called as DT tagger, and seashore is a noun, so it is called as NN. And then we have named entity recognition. This method involves identifying and categorizing named entities in a text such as people organizations, and locations. NLTK provides a built-in NER classifier as well as the option to train your own classifier. Consider an example. Barack Obama was the 44th president of the United States. So the named entity recognition output would be Barack Obama. He's a person. And the 44th, it is an ordinal which is used for ordinal numbers. And United States is used for geopolitical entities. GPE tagger. Sentiment analysis. This method involves determining the sentiment or emotional tone of a text. NLTK provides various classifiers and tools for sentiment analysis. Consider an example. I loved the movie. The acting was amazing and the plot was captivating. Sentiment analysis output. It's positive. And consider another example. The restaurant was terrible. The food was cold and the service was slow. And the sentiment analysis output would be negative. Advantages of using NLTK for NLP are: it is an open source and freely available. It has a large community of users and contributors providing a wealth of resources and support. It provides a wide range of NLP tools and functions. It is easy to use and learn, especially for Python programmers. It is highly customizable, allowing users to build their own NLP models and classifiers. And some disadvantages of using NLTK for NLP are: it can be slow and memory intensive, especially for large data sets. It may not always provide the most accurate results, especially for more complex NLP tasks. It may require some programming knowledge and experience to use it more effectively. It may also not be suitable for all languages or all language varieties, as it is primarily focused on English. And some of the challenges faced by NLTK function are processing speed. The processing speed of NLTK function can be slow when dealing with large amounts of data. This can make it difficult to work with large data sets. And the solution for this is to use more efficient algorithms or hardware. Another solution is to reduce the amount of data being processed, for example, by filtering out irrelevant data. Accuracy. While NLTK functions are generally accurate, there may be cases where they fail to accurately identify or classify certain aspects of the text, leading to errors. And the possible solution is to use more advanced algorithm or techniques to improve accuracy, such as deep learning or machine learning models. And another solution is to manually review and correct errors. And the variability in language. Natural language is highly variable and can vary widely between different regions, cultures, and even individuals. This variability can make it difficult for NLTK functions to accurately process all types of data and language. So the possible solution is to use domain-specific models or algorithms that are trained on data from specific regions or cultures. And another solution is to develop more advanced algorithms that are able to adapt to different types of language. Limited language support. NLTK functions are primarily designed for English language and may not work as well for other languages. The possible solution is to use language-specific libraries or tools that are designed for specific languages. And another solution is to develop a new algorithm or techniques that are better suited for other languages. And now my friend Raghu will continue this presentation.
Thank you so much, Narendra. Hi guys, this is Raghuram Raju Nadimpalli. As you know, Narendra already taken you through the overview of NLTK. Now I will take you through the example that I have developed the code in Python, to perform the word tokenization or the sentence tokenization, to find the sentiment analysis and stemming, lemmatization, everything in Python. I developed my own code, so I will take you through the that code entirely and how to use the NLTP methods to perform all these word tokenization, sentence tokenization, etc. So for that, for first of all, you need to install NLTK in your PC. So to do that, I have this link. I will be posting this link in the description, so you can go to this link, and this is the NLTK documentation for both Mac and Windows. There will be steps in this for Mac and Windows. You can just simply run these steps and can install the NLTK simply. Before installing the NLTK, make sure you have the Python in your PC, because there is a reason why we use Python, because NLTK library is built in Python and provides a user friendly interface that makes it easy to use its features and resources. So this makes it possible for developers and researchers to use NLTK and to build NLP applications in Python, with minimal coding effort. So that's why we use Python to implement all the NLTK methods. So this is the enter documentation, so you can use this documentation to install the NLTK. So let's get to the code that I have developed here. So alright, let's get started. So first of all, I did a sentence tokenization. To perform the sentence tokenization, I have imported the nltk.tokenize package. From there I can simply use the sentence tokenize method to perform tokenization sentence wise for the data that I have taken. So for example, this is the data set that I'm using for this particular code. You can use whatever the data you have. So this is the data that I have I'm using for now in this project. So this is the data set. I am importing that file to this text. So I'm just converting whatever the data is there in that particular text file. I'm just reading it into this text variable. So and what I'm doing is, whatever the output I'm coming from this code, I'm getting from this code, I'm writing it into some output file. So for example, let's say here I'm doing sentence tokenization for the main data, which will have the all text of that particular data set that I have. So it will do sentence tokenization, and from there what I'm doing is I'm just writing the sentences that I got. Each sentence will convert into a token when we use this method. So all the sentence tokens will be I will be writing it into the particular file called output file. So let's just run this code for now. Yeah, the code was finished, and let's check. This is the dataset output. You see, I'm writing actual data from this particular command, and after that this is the sentence tokenize. And if you see, from here to here, this is one token. That means it is one sentence. So one sentence is converted into one token, and this will be my second sentence. So second sentence is my second token. In the same way, all this data, so each sentence will convert into a token, because we're doing sentence tokenization. After that, we have word tokenization. Word tokenization is nothing but we're converting each word into a token from the main data set that we have. So to do word tokenization, it's also from nltk.tokenize package. From there I'm using word tokenize method simply. So these all are an NLTK like NLTK methods. This all comes from the NLTK package. So and this one is word tokenization. What I'm doing is I'm simply using the whole data that I have in the dataset. I'm just using word tokenize method and converting them into the tokens. So in words, I will have all the tokens, all the word tokens, and I'm writing all those words into my output file. So let's just run this and I will show you the output. So it's done. I'll just open this again. I just have to refresh it. Alright, if you see, this is sentence tokenization that I already shown you before, and this is now the word tokenization. If you see, the one is converted into a token, and of is converted into second token, the is converted into third token, most. In the same way, each word is converted into a single token. So that's called word tokenization. What is stemming? So next I'm doing stemming. Stemming is nothing but it will just remove all the suffixes of the word. For example, let me just show you the word. If you see in this, let's the stories, the ies is nothing but it's a suffix for that particular word, so it will just remove all those suffixes and it will be like a story. That's it. Same with like ears, it will just convert to ear. Occurred, it will convert to occur, in the same way. So to do this stemming, I'm using method called port stemmer. This is from the package called nltk.stem.porter. From there I'm using this porter stemmer, and so using that porter stemmer I'm just stemming all the words. Before that I'm what I'm doing is I'm just stopping all the stop words here. What are stop words? Stop words are nothing but these of whichever the stop words in the sentences. All the stop words will be removed using this stop words command, this command, where I'm make sure that the stop words contains all the words in English, like all the stop words in English, which is of, the, and a, everything in the stop words. So using this particular line I'm removing all the stop words from all the words that I have, which I've already tokenized, and from there I will simply do the stemming for all the words. That means it will remove all the suffixes if there is any suffix in a particular word. So let's just run this code. Alright, it's done. Let me just close this and reopen it again so it will refresh. Alright, so now I got the stemming. If you see the difference between word tokenize and stemming, I have one of the most, these all comes under stop words, that's why they are removed. And if you see remarkable, this suffix was gone and now it is remark. And stories converted into story. Of is a stop word. Survival, the previous suffix was gone, it's now survive. So in the same way, lemmatization is also like almost similar to the stemming, but there's one difference, which is it converts to its base form. For example, as Narendra already mentioned, word will be converted to be. In the same way, whatever the words we have, all the words will be converted into their base form using lemmatization. So for lemmatization, I'm using a particular method called class called lemmatizer. In that class I'm using a method called lemmatize. So I'm getting this wordnet lemmatizer from nltk.stem package, and from there I'm just importing the class that I have, wordnet lemmatizer. I'm just converting this method to a variable called lemmatizer. From there I'm using lemmatize method, and again whatever I'm doing for the stemming, I mean removing the stop words. So after removing the stop words, whatever the words I filtered, all those filtered words will go under lemmatization. That means they just convert into their base form. For example, let me just run this code. Alright, and I'll just close this and reopen it again. Alright, so now if you see, we got the lemmatization, and if you see, they go into their base forms from the word tokenize. Of the most, these all are stop words, they are removed. And remarkable is remarkable, stories convert into story, and survival is survival, recent is recent, years is year. So this is all the base forms of those particular words. Alright, so now after lemmatization we have pvos tagging. So pvos tagging is nothing but parts of speech tagging. In parts of speech we have a lot of taggings. For example, like nouns, verbs, everything. In nouns we have a lot of subtypes. In verbs we have a lot of subtypes. So each word will have a particular POS tag. So in this POS tag we are simply like finding out what POS tag for should have for a particular word. For example, let me just run this code and close this. So yeah, so this is my output, and these are like tags CD, JJ, and each have their particular abbreviations. These all comes under parts of speech taggings. So one comes under a group called CD, remarkable comes under group called JJ, stories POS tag ZNS, and in the same way each will have must come under some POS tag. And after that we have name entity recognition. Name entity recognition is nothing but if there are any names coming, then it will simply make sure whether the particular name is for a person's one or organization ones or anything else. In the same way, whatever other POS we have, it will, whatever the subtypes we have, it will make sure to describe what particular POS it is. For example, let me just run this. Alright, it's finished, and let me just refresh it. So if you see here, I'm just finding only few. For example, I've just filtered only few names, few name entities. For example, only that comes under names. For example, Thailand is a name of particular a country, so that's why it is tagged with GP. And Wild Boars is a name, person name. Tam Luang Nangnon is a person name. So if a name is tagged to a person, then the name entity recognition will be person for that particular name. If it is Thailand, it comes under a country or mostly country, so that's why it will be the name entity tag will be GP. So I've just filtered only names in this. You can filter, you can change the code, and you can find out for other POS tags, and you can find the name entity recognition. And at the end we have sentiment analysis. Sentiment analysis, we use this. This is one of the main thing in NLP, sentiment analysis. Why? Because all the data is mostly managed by sensitive analysis, whether the particular sentence or particular file comes under positive sentiment or the negative sentiment. They they go under get some values like polarity values for each sentence or a file, and based on that they rate the particular file or sentence, whether it is a positive sentence or it was a negative sentence. And using that we can make sure the particular data set is positive accurate one or not, or the negative accurate one or not. So sentiment analysis is very important in natural language processing. And to perform sentiment analysis in NLTK, we have a method called sentiment intensity analyzer, and this we got it from nltk.sentiment.vader. We also have another one called text block, but it does not include in NLTK. Vader is one of the package is included in NLTK, so we can simply use Vader, and we can use sentiment intensity analyzer class to find out the polarity scores, whether the particular sentence is positive one or negative one. So if the POS if the polarity score is greater than 0, that means the sentence is positive. If it is less than 0, then it is negative. So in the same way we can find the emotions of the particular if you wanted to find the emotion for the sentence, then you can do it on sentence wise, and if you wanted to find out on file, then you can do it on file. Let's just run this and I'll show you. All right, see, for each sentence I did a sentiment analysis, and I got these values, and from that the POS is most important one for us. Using POS, then we can make sure whether it is positive sentence or negative sentence. So here it is greater than 0, so that's why the sentence is positive. Here it is exactly 0, so it is comes under neutral. And in the same way, we might have some negative values, they comes under negative sentences. So that's pretty much that we did for NLTK project. And you can change the thresholds in sentiment analysis, like making sure you can change the polarity like 0.09. so it will make, what will happen is you can get more negative accuracy, which is of course not good for a positive data sets. But in order to find the best accuracy, you can change the threshold values from 0 to like 0.09, 0.05, 0.9 until you get the best accuracy of the data sets. So this is how we built the code for for doing sentence tokenization, word tokenization, stemming limitation, POS tagging, name entity recognition, and sentiment analysis. All right, that's pretty much from my side. I'm using IDE environment here. So if you want to use IDE I'm pretty much comfortable with IDE, so that's why I use IDE. If you wanted to use Python interface, you can simply use the Python interpreter and you can run. For this you have to install the NLTK and Python for sure. But for IDE, if you wanted to use IDE, you can simply create Python project, and if you wanted to install NLTK for this IDE, you can simply go to Python packages, and from here you can see NLTK. Because I have already installed, I don't have any install button here. If you don't have, you will get a button called install, so you can install from it here. So that's pretty much from our side. Thank you so much, and if you have any questions, you can. Thank you. Bye bye.